Okay, so this is, I really like this though, because this is a good example of something that we try to do in math. In math, as much as we can, we try to take a very general situation and solve a completely general equation so that the answers are also totally general. Now, we're used to doing stuff like this. Like if we had, for example, let's say we had the quadratic equation. How about if we had 3x squared minus 2x plus 1 equals x squared plus 7. What would we do to solve that based on what we already know? Say it again. Okay, so yeah, we're going to push everything over to one side, aren't we? We want to put all the terms on the side where we end up with a positive number of x squareds. Okay, so we're going to subtract everything from the right side to the left side. And that's going to give us 2x squared minus 2x minus 6 equals 0, right? Okay, agree? Now we're just going to solve this quadratic equation. So what are some things we can do to solve this? Say it again. Put the 6 on the other side. You're getting at maybe completing the square, right? Okay, good. Yeah, we can do that. Is there anything we can do before we even start to make this easier? Okay. Yeah, we could factor out of 2, couldn't we? Greatest common factor of 2. If I factor out of 2, what am I left with? X squared, whoops, minus x minus 3. Okay? And now, being as this is an equation, I can divide both sides by 2, can't I? Right? And get rid of that 2 completely. And so if I divide both sides by 2, that effectively just cancels that out. And I end up with an easier equation to deal with. X squared minus x minus 3 equals 0. Okay? Now, we got to be careful with that. If we were doing the kind of problem where it said, let's say instead of this equaling 0, what if we instead had this like y equals that stuff? And it wanted us to write this in vertex form. Then I can't divide by 2 and get rid of it, can I? Because the 2 is important. The 2 is the value of a that helps determine what the shape of that parabola is going to be like. But if I'm not doing that, if I'm just solving a quadratic equation, I don't really care what the parabola looks like, right? I just want to get the solutions. I just want to get the values of x that work. And so I can always divide both sides of an equation by a constant, and that's okay to do. I just can't divide both sides of an equation by a variable. Okay, that's a no-no, but I can always divide both sides by a constant. So I didn't even really have to factor this 2 out, did I? You see what I'm getting at? I could have just divided both sides by 2, because I can see that 2 goes into each of my 3 terms on the left side, and probably just gone straight from here down to that step. Does that make sense what I just said? You can factor it out and then divide if you want to, but if you're comfortable doing it, you can just divide both sides, term by term, by whatever constant divides into everything. Okay, and just skip right into this. Okay, now though, let's get on to completing the square. So what do we do? Okay, add 3 to the other side. Good. So we end up with x squared minus x equals 3. Now what? What do I have to do? I have to add just the right thing to both sides, don't I? Yeah, what's b in this case? Negative 1. So if b is negative 1, what's b over 2? Negative 1/2. Okay, and I'm going to add b over 2 squared, aren't I? So I'm going to add the quantity negative 1/2 squared, which is just what? 1/4. Okay, and the reason I did that, remember, is so on the left side, I would get a perfect square. What's my perfect square going to be? Not x squared. X minus 1/2. Good. X plus b over 2. Right? So x minus 1/2. Quantity squared. There's my perfect square. I created a perfect square trinomial which factors into this. On the other side, I'm just left with what is that, can be 13/4?
Yes.
And now, from this point on, the whole point of that was, so I could write this in terms of a single x that I could then solve for, right? So here's my single x. What are the steps in order I would do to isolate that x? Square root both sides, good. Okay, so if I do that, I'm going to get x minus 1/2 equals square root, okay, almost. Plus or minus, good. Plus or minus square root of 13 over square root of 4, which is just 2. And then the last step, add 1/2, good. And so my final answers look like x equals 1/2 plus or minus the square root of 13 over 2. So I get 2 of them, right? Okay, and we know how to do that. But in the case where we end up with, big coefficients of a, and I mean, it ends up being a little bit of work involved in that. Could we come up with, though, instead, could we come up with just a formula that's always going to work, right? So where would we start with this formula? We want to be as general as we possibly can, so we're just going to start with a general quadratic equation in standard form. Okay, so now what does that look like? Okay, say it again.
Is that like the all variable?
Right, that's the one where we don't know what any of the coefficients are. We're just going to call them A, B, and C. We're not going to specify anything. We want to be completely general with this. So we got the equation ax squared plus bx plus c equals 0 because it's in standard form. We can put any quadratic equation into that form by just gathering all the terms on one side, can't we? Right? So that's a great place to start. We do want to, and it'll work both ways, but we do always want to make sure that A is positive. And real quick, how could I do that? What if I had, for example, what if I had something like, what if I started with something like this? What do I do to make this look better in standard form? What if I had negative 3x squared plus 7x minus 5 equals 0? Is that in standard form? Well, kind of, but we don't want a to be negative, so what would we do? Yeah, multiply both sides by -1, which just changes all the signs, doesn't it? So we would multiply both sides by -1 and get positive 3x squared, negative 7x, and positive 5, right? Okay, but we can always get into that form, is my point. All right, so now what we want to do is we want to complete the square generally. We don't even have numbers for A, B, and C, but we can still do that process that we've always done to solve for x. And when we're done, we're going to get x equals, notice see where this is going to go, we're going to get x equals 2 answers that involve A's and B's and C's, right? And then we could just say, okay, well, in our situation, what's A, what's B, and what's C, and plug them into that formula, and that'll be our answer. Make sense? That's our strategy. That's our approach to this. So let's do it. So what are we going to do to complete the square here then? Step 1. Okay, good. We got subtract c. Good, because our goal is to get on the left side, we want to get x squared plus some number times x, right? So we subtract c, and we get ax squared plus bx equals negative c. Now what?
Divide by a.
You got to divide both sides by a, don't we? Okay, we got to get that at 1x squared. So if I divide both sides by a, what does that leave me with? Well, over here, let's just break this up into 2 separate fractions. Ax squared over a is what? X squared, like we wanted. Okay, now what about this? Bx over a, well, we can't really do anything with that, can we? We're just going to call that b over a times x. How about, yeah. And on the other side, we just end up with negative c over a. Okay, but we can still complete the square with this. Now, it's a little confusing to talk about this in terms of b, because we've already got a b in this, right? But what we used to call b, like the old b, what does that equal to here? I'll make it a capital B to distinguish it from this other b that we already have in our equation. So what is our capital B, what we used to just call b, the coefficient of x? B over a, yeah. So the old b is the new b divided by a. right? So then what's the old b over 2? 1/2 of the old b.
Oh, b divided by 2a.
b divided by 2a. Dividing by 2 is the same as multiplying by 1/2, isn't it? So the old b over 2 is the new b over 2a, right? Okay, and so I need to add to both sides this squared, don't I? Right? The old b over 2 squared. So plus the quantity b over 2a squared, which is what if I square both the top and the bottom? What's b squared? B squared, right? What's the quantity 2a squared? 2a times 2a. I think I heard it. 4a squared, right? Okay, so on the left side then, we just completed the square. And so what do we end up with? What does all this stuff collapse to? We created a perfect square trinomial that we could write as a perfect square. What do we get?
Plus b over 2a.
Okay, good. X plus old b over 2, which is b over 2a, right? Quantity squared. On this side, let's do a little addition of fractions. If I wanted to get a common denominator here, what would it be? I've got two fractions. B squared over 4a squared minus c over a. So what's this is a little strange, but what's going to be the least common multiple of 4a squared and a? Well, I don't know what a is, so I can't say 4. But couldn't I multiply the black fraction on the left here by top and bottom by something to make it have the same denominator as the blue one? 4, at the bottom I need to have a 4a squared. I've only got an a, so I got to multiply by, I need a 4. And a times what is a squared? A. So I got to multiply the bottom and the top by 4a. Does that make sense? Okay, that's going to give me my common denominator of 4 times a squared. On the top, I'm going to get a 4 times an a times a c. Right? So would you agree then that if I do that, on this side I'm going to get a common denominator, you already told me, 4a squared. On the top, I'm going to get b squared minus, if I just write these in alphabetical order, 4 times ac times a times c. Make sense? Okay? Well, we're getting there. Now, all we really have to do is just isolate x, and we're going to have an answer that always works if we know what a and b and c are. Yes, Julia?
Did we already do this?
Oh, did we do this
Yeah.
period? We didn't do it fourth period.
Yeah.
Oh, we did. You're right. This period we did. You're right. But the classes are kind of mixed up now. So some people are. So we're almost done. Well, we did. We didn't do it fourth. You're right. Okay, so then, real quickly, we would just square root, right? And subtract this term away, and we're done. Agreed? So if I square root, we get x plus b over 2a equals plus or minus, right? Plus or minus the square root of b squared minus 4ac over 4a squared. But we can split this up into the square root of the top and the square root of the bottom, right?
2a, right?
Yeah, so on the bottom, 4a squared is just the quantity 2a times 2a, so 2a squared. Right? And so we end up with, on this side, plus or minus, the top we're stuck with, right? B squared minus 4ac. On the bottom, we've got 2a. So the last step then would be to do what?
Subtract b over 2a.
Yeah, subtract that term to the other side. And we end up with x equals, did I even show you guys the song for this?
No.
I did,
You were
okay.
going to, but you didn't.
Oh, we will. You'll get to see the song. So we have a common denominator of 2a, and this is the glorious quadratic formula. This always works. Okay, so you know then x equals negative b plus or minus the square root of b squared minus 4ac
I wanna write that down.
Whoops, forgot the C. All divided by 2a.
On the two upper part, you
I'm writing this down.
Did I forget? Oh, I forgot the C there too, didn't I? Yeah, no wonder. Okay, there we go. Right? Okay, now this is very useful. It's useful for a couple reasons. So if we start with
Let's try and copy that down.
quadratic function in standard form, then that always gives us, by the quadratic formula, the solutions. Negative b plus or minus square root b squared minus 4ac, all divided by 2a. Okay, how are you going to get imaginary solutions here? What's the part that's going to make them imaginary? The square root part, isn't it, right? It's whatever's inside the square root would be negative. I'm going to get real solutions and no imaginary solutions if whatever's under the square root is positive. Agreed? That makes sense? Now, there's one other kind of in-between process here. By the way, we call this stuff in the middle here, we call that the discriminant. The stuff that's in the middle of that, or that's stuck inside the absolute value. The discriminant we usually just call capital D, and that's just b squared minus 4ac. We know right away by evaluating that, and that's where you always want to start with this formula, because lots of times we're only looking for real solutions. And so you can just start with the discriminant, calculate what it is, and if you get a negative answer, just stop. Because you know you're going to get i's, don't you? Right? So based on the behavior of the discriminant, we know that if d is greater than 0, then we get 2 real solutions. Right? If d is negative, so it's less than 0, we get 0 reals. And it turns out that they're both imaginary. Okay, well, what happens if the discriminant is exactly equal to 0? What if b squared minus 4ac equals 0? Then that term drops away, doesn't it? I just get a 0. What's the square root of 0? 0. And so I get negative b plus or minus 0. Well, adding 0 and subtracting 0 is the same thing, right? In that case, don't I just get negative b over 2a? So how many real solutions do I get that time? 1. So that's the in-between case. If the discriminant equals 0, then we get 1 real double solution. Okay, make sense? Okay. So very handy. You're going to get, a lot of times, it's already simplified, isn't it? Half the battle with completing the square is to turn this thing into a simplified, get the radical simplified, get all that stuff. Look, it's already done. It's already done. You end up with a number plus or minus a square root. Either that radical is going to simplify or it's not, divided by some other common denominator. It's already in the right form. And honestly, a lot of times, we don't even care if that radical is simplified. To me, really, it's as good just to say something like the square root of 108 as it would be to break that up into 6 times the square root of 3. It doesn't really matter, because they're both exact answers, and when I plug them into my calculator, I get the same decimal back. So a lot of times, I'll ask you on Moodle when you're doing this stuff, don't have to simplify this, but just give me an exact answer. Just whatever the quadratic formula spits out, that's the answer we're looking for. Does that make sense? Okay, because it's exact. And then a lot of times I'll even have you round these things. A lot of times we just want to know what's the solution rounded to 3 decimal places or something like that. Okay, and if it has an imaginary part, you just round both numbers to 3 decimal places. Okay. All right, so I'll show you the song. You'll never forget this once you hear this Gorky song a few times.
I still.